All to say, these systems allow us to think differently about how we design an experiment and how we can address greater diversity when we look at a library of enzymes. If we are trying to solve a critical bottleneck in a pathway that we are engineering in a new host, we would love to be able to run a high throughput screen that lets us look at 50,000 unique enzyme sequences in some cases, or possibly 2 to 3,000 with unique experimental inputs and conditions. And so with these integrations over time, we've been able to write software at the very boring level that lets new drivers come about so that disparate third-party software and hardware can talk to each other. Very boring, but important. That you can upload data and process it and have good quality control metrics, because when you get to that scale of handling 10,000 samples in a batch, you need cameras, you need different logic for liquid level, you need different logic for transfer success validation, because you just can't get your head around that. And very importantly, you also need software that remembers what sample was in what well, what's the genotype of my strain in well A3, what reagent did I add to it at what time. And so we had to write all of that logic out that let these work cells typically replace the work of anywhere from 6 to 20 people in a given week. Now, we didn't fully replace those people. Those people became very good at working with software and automation, and it let them think differently again about how they would design an experiment. And so for us, oftentimes, we could then kind of push the envelope in how we would introduce diversity, be it combinatorial mutagenesis in a library of proteins, looking at combinatorial libraries of regulatory parts for driving gene expression, and running them on these systems at scale. Also, importantly, developed these both for microbial hosts and mammalian hosts, and added the needed containment to work with iPSC-derived cell types, primary patient samples, and doing different new workflows that we're offering to our partners in functional genomics and antibody developability in high-content imaging. And so overall, feel very comfortable when we're in that rational arrayed world of handling one genotype per well, of working with 10 to the fifth cell designs or experimental conditions. So then on to sort of generation 4 of integrated automation. We are developing internally a technology that we call RACs, or reconfigurable automation carts. We believe that these systems get around those design headaches and stress that I touched on before, when I don't know if I'm designing the perfect work cell for 6 months from now, but it's going to take me 6 months to build it. And so here the idea is that we take laboratory hardware and enclose it in a reconfigurable automation cart. There are interlocks that allow this cart to merge up to a maglev rail. And so with that, what we can do is essentially have a Lego set for liquid handling robotics, for analytical systems. And so the idea is that we either have these on wheels where they come up to a rail, or in other cases, we have a sort of more streamlined version we call tiles, which can go into a tissue culture hood. We have a partnership with a national lab, for example, where we're putting these into custom anaerobic chambers, and we're able to run culturing and analytics with strict anaerobes. And so just thinking about like the sort of flexibility or the scale that you want to move to with these systems, we can offer that to our collaborators. And then in-house, we have a fairly large system that we continue to add to and refine, where we're able to run a large library of services for sequencing prep, for setting up digital PCR, RNA sequencing, cell cultures, where we're able to use our in-house software to interleave different protocols so that we're making the most efficient use out of this hardware as possible in the footprint of our lab space, in truly a walkaway manner for many of these protocols. And so, racks collect into these rack systems. This is a rendering of another real system that we've built with a partner that lets us run large batches, and again, importantly, multiple different protocols thinking about how to sort of be that train conductor and having everything run in the most optimal way so that you're making the best use of your hardware. We continue to do all of that boring but important work of bringing on new hardware so that we can have new capabilities and protocol steps that are supportable.